Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to talk about what exactly is machine learning, why do we have machine learning, what is a supervised and unsupervised form of machine learning, what are the further subcategories of both of these, and also what are the different machine learning algorithms that we are going to learn as well. So let's move ahead and see exactly what we have for today. But before moving on, do remember to subscribe to my channel, and also you guys can connect with me on LinkedIn, and I will leave the link in the description box as well. So when we talk about machine learning, we all, most of us, in fact, most of the audience has been working on the data side. So they already know, we try to take the data from the multiple ingestion sources. We ingest the data from multiple sources. We try to transform the data, and then we basically keep it for the use of the, BI purposes. So this has been the traditional pipeline that was going on, right? But now, from the onset of this artificial intelligence, from the past 10 years almost, now we are also supposed to provide meaning to our data, not just in form of the dashboards that we have been creating, but also in form of artificial intelligence applications. So now when I say AI applications, what exactly do I mean? I mean that the data that you have should be able to provide meaning to you, without human intervention. It should be able to do same tasks as human but without human intervention. So due to which this field of machine learning, data science, or artificial intelligence came into picture. Now artificial intelligence is the end goal, right? Artificial intelligence application is the end result. Your self-driving car is actually the end result. So what does self-driving car do? It makes use of the data, cleaned data that a data engineer has provided, and on top of that we run few algorithms, and that through the use of that algorithm, through the output of that algorithms, self-driving car is able to understand what should be the next step, right? So it is able to mimic human brain. It is able to understand what should be the next step without a human directly telling self-driving car what to do. So that is an artificial intelligence application that we use. Now machine learning basically is a subset of artificial intelligence, where basically it helps you by providing you statistic tools and algorithms that will help you to analyze and visualize the data. Now when I say it will help you to analyze and visualize data, it has set of algorithms, some set of statistical tools that you can actually utilize to build your models. Now once you build those models can actually get trained on the data, right? That model can get trained on the data that you have, and in future it can help you to forecast and predict what would be the next step in case similar data arise, a similar data is passed to the same model. So that is what machine learning is all about. So machine learning is nothing but it is a subset of artificial intelligence. It provides you statistic tools to analyze and visualize the data, to forecast and predict. It will be able to tell you to it will be able to tell self-driving car to go left or right based on, it's based on the data on which it has already been trained, right? So that is what the machine learning is about. So when you talk about machine learning, it is broadly classified into supervised and unsupervised machine learning, right? This is a normal term which I think most of you would have heard at least from the past 5 6 years very easily. Supervised and unsupervised machine learning. We are going to discuss what exactly it is about. And supervised machine learning is further classified into classification and regression. So when I say classification and regression, supervised machine learning is a subject area, unsupervised machine learning is a subject area. Now what kind of problems can you solve by using supervised machine learning algorithms? Similarly, what kind of problems you can solve by using unsupervised machine learning problems? Now, those problems are themselves classified as classification problem, regression problem. Classification is further, divided into binary and multi-class. Similarly, unsupervised machine learning, what kind of problems it can solve? It can solve clustering problems, dimensionality reduction problem, anomaly detection problems, right? So this is how, this particular flow diagram, this is what this flow diagram means. I request you all to pause this video and make sure that you are very well aware of this particular flow diagram, and we are going to discuss each of this as well. So when we talk about supervised and unsupervised machine learning, when we go further in discussion for that, the first thing that we should know is what is a dependent feature or variable, what is an independent feature or a variable. So when I talk about a model, right? When I talk about a model, that for any of your AI application, machine learning is basically going to provide you some set of statistic tools, right? That will help you to analyze the data, right? So basically, you end up building a model, right? You end up applying a model. Now, on top of that, the data that you will input to the model, right? The data that you will input to the model, that is usually called as your independent feature or a variable, right? So for example, in case of self-driving cars, right, you are inputting the data to the self-driving car that okay, if you see any object, if you detect any object within 1 meter of proximity, just apply the brakes, right? So that is an input data set that you provide to that particular piece of model. So that becomes your independent feature or variable, the input for the process that is being analyzed, right? So that is an input. When you talk about dependent feature or variable, it is nothing but it is the output of the process. What is the output? That is the dependent feature. So for example, I will take another example. So let's say you have a piece of land, right? So in the model, you want to build a model that will be able to tell you the price of the land, provided you type in the area of the land, right? That is what you want. Now, in that case, area of the land is an independent feature, right? And price of the land is a dependent feature. Why? Because the price of the land is actually dependent on your area of the land. That is why the price of the land is an output which is actually dependent on your input, right? Your input is passed to the hypothesis. Your input is passed to the model. After passing this particular input, you run a set of algorithms which we will be learning anyway, and then you provide an output prediction, which is your price of the land. So that is how you even make use of the data. So I hope you understood what is independent feature and dependent feature. Now this will help you to understand the whole flow diagram that we saw. Now, if you see, I'm going to talk about supervised machine learning. So when you talk about supervised machine learning, so whenever you have an output data set, right? Whenever you have output data set, like you have a price of land, whenever you have a dependent feature available, right? In that case, it is called as supervised machine learning. Now, this is a very short explanation, right? Whenever you have an output feature available, that is a supervised machine learning. Now, supervised machine learning will always use a training set to teach your model, right? And that training set will also contain your desired output. So, in the training data set, you are going to give the area of the land, and you are also going to give the price of the land. So it is going to learn, the model is going to learn based on your input data set, and your input data set will have both your input as well as the desired output. It is going to learn from there, and then in future, it will help you in predicting the price of the land based on the input that you provide. So that is what is called as supervised machine learning, right? So in supervised machine learning, it uses a training set to teach models to yield the desired output. Now, in this case, the training data set will include both your input and also the desired output. So, your desired output is the price of the land. So, your input during the training data set will always need what? It will always need the price of the land as well. You will need price of the land as well to train your model. Now, this algorithm basically, you have to make sure that, there is an accuracy as well involved in the outputs, which we are going to learn in the different algorithms as well. So, we always have to minimize the level of error. So, we always use few loss functions through which we try to minimize the loss, or we try to minimize the variation and provide the accurate result. Now, similarly, supervised machine learning, example is, the area of the land predicted, predicting price of the land based on the area of the land, right? So that is example of your supervised machine learning. Now, supervised machine learning, as you see in this flow diagram, it is further divided into classification and regression problem. So let's discuss what is this classification problem. Now, classification problem basically uses an algorithm to accurately assign test data into specific categories. So when I say that, let's say you have set of input features, right? You have, let's say, marks obtained, right? And when you have marks obtained, and to a particular model you are passing the input feature of marks obtained, you are also passing the output whether that person is pass or fail. You are training that particular model based on this, and in future when the data comes, your model is able to predict, your model is able to tell you whether a input mark is and out is a pass or a fail. So your output is always two. Either it is pass or it is fail. It is classifying your input data set, right? What it is doing, you are giving marks as an input. The output is the classification. It is trying to classify the output, right? It is trying to classify your input into two sets, pass or fail. So that becomes a classification problem. So it tries to label your data in terms of, it tries to kind of classify your data, right? Now, similarly, whenever you have two, classifications. So the example that I gave you, marks obtained is the input and the output is pass or fail. So there it is a binary classification. You have two outputs. But let's say you train your model based on the fruit color, fruit shape, right? So you're training it based on fruit color, fruit shape, and you're telling your model that, okay, if the fruit color is red and the fruit is more of a circular shape, then it is an apple, right? So you are training that particular model, and the output is not binary, right? Because when I say not binary, the output does not have two values. It has more than two values. It is classifying your data on more than two values. It is called as multi-class classification. So in this case, this is what? This is nothing but this is your supervised machine learning, where you also have to pass input as well as output to the model, and you have a desired output, right? And in this case, classification, you have two types of classification: binary classification and multi-class classification. So now let's talk about another supervised machine learning problem that we solve, that is a regression problem. So till now we have talked about classification problem. Now when you talk about regression, what is a regression? In case of regression, you know, there is no proper classification that you are doing on the input data set. In this case, what you do is you provide set of input features, you provide set of input, and the output is a continuous variable. Output is not set, right? Output is not like it will be always true or false. Output will not be always like pass or fail. Output will always not be like apple, banana, grapes, or oranges, right? So it will not be a set output. It will be a continuous output, and this continuous output will be based on a relationship between your input features. So for example, if the input feature is a land area, land location, and the type of a land. So if you buy a land, let's say in a good area, in a good location, in a good location, and you have some specific size of the land. So let's say 100 square feet, 1000 square feet, 2000 square feet, specific area, specific location, type of the land, whether it is a commercial land or it's a residential land or it's an agricultural land. So based on these input features are detrimental in determining the land price, right? So what happens is the land price can vary. It can vary. So there is a relationship between these features which determines your land price. So your land price will not be like set variable, right, which is dependent on your input features. No, it's not going to work like that. There will be a relationship between this input feature and the output. Based on that relationship, always your model is going to define the output price, which will be a continuous output. So that is what your regression problem is all about, right? So this is what your regression problem is all about. So this is what we have discussed about supervised machine learning. If I go back to this flow diagram, now let's talk about unsupervised machine learning. Now, remember that unsupervised machine learning, will be pretty much opposite of your supervised machine learning, right? Now, the moment I say unsupervised machine learning, right, what does it mean? It is trying to solve a completely different set of a problem than your supervised. Now, supervised is trying to solve your classification problem, your regression problem. Unsupervised machine learning Basically, it has set of algorithms that infer the pattern from the data set without reference to the known or labeled outcomes. In this case, what is happening? I'm not giving any output as well to my model along with the input, right? In this case, that is not happening. In this case, I'm providing my model the input set of data and I'm trying to segment it. So usually supervised machine learning is used to segment the data set, right? To segment the data set. So when I say that, let's say I try to give input as the customer age. So the moment I'm trying to give customer age as an input, I want my model to tell me whether this particular customer is, like let's say I give age as an input, and the model has to determine what age group does that person belongs, whether he's an infant, whether he is in his adulthood, whether he's in middle age or he is an old age. So that kind of segmentation, if it has to do, now I have given you a very simple example, right, just to understand. Now if you see, the model will take the ages as input and it will try to cluster the output. It will try to solve this clustering problem. It will try to label the customer as whether that particular customer comes in the group of old age people or that particular customer comes in the group of infant, right? So that is what your machine learning is about. In this case, unsupervised machine learning does not have any output data that you provide in to train the model. That doesn't work like this. It tries to solve the classification or the clustering problem. So the major problems that are solved by unsupervised machine learning, that is a clustering problem. In case of supervised, it was more of a classification and regression. Sorry, I said classification earlier in unsupervised as well. So unsupervised will only solve your clustering problem. It will try to group your data together. It will try to group your data together. In supervised, it will try to classify your data, or it will try to solve your regression problem based on based on how your input features are correlated with the output. In case of unsupervised machine learning, you are trying to cluster or group the input data set, based on few rules. So, for example, when you talk about customer segmentation, for a particular company, you want to understand that these particular set of customers, can you sell this particular product? Can I sell this particular product to a group of customer or not? So, in that case, whatever customers I have, I'll try to segregate those customers, right? If the product that I want to sell fits to a particular customer group, I will only fetch the customers from that particular group, right? And try to sell my product. So that is how it helps. So similarly, anomaly detection. So when I say anomaly detection, unsupervised machine learning helps you to detect the anomaly as well. So for example, when you are inputting the data set, if there is any unusual data points that are detected in your input data set, so that also can be recognized by your unsupervised machine learning itself. So for example, any kind of fraudulent transaction comes under this. Now, similarly, there is something called as dimensionality reduction. So, let's say for a particular piece of a problem, you have 1,000 features, 2,000 features, 3,000 features, and you want to reduce the number of features, right? In that case, we go for latent variable model or something that is called as dimensionality reduction. Both are the same thing, they are used interchangeably. So, in those scenarios as well, your unsupervised machine learning is very helpful. So I hope you understood this. And also, I have put together few machine learning algorithms, although there are a number of algorithms. So when you talk about supervised and unsupervised, right? So specifically for your classification, you have decision tree, you have random forest, you have logistic regression, you have XGBoost, you have your artificial neural network, you have CNN, you have SVM. CNN is mostly for your images. So basically, these are the algorithms that are used when you are trying to solve any classification problem. When you're trying to solve regression problem, it is you use basically linear regression, lasso, or you use decision tree regression, random forest regression, ANN, RRN. So all these are the ML algorithms that we need to learn when you are trying to solve a regression problem in supervised machine learning. Now, similarly, when you talk about unsupervised, where you are trying to solve a clustering problem, right? In that case, You kind of use k-means clustering, hierarchical clustering, your DB scan, your nearest neighbor clustering. So these are different machine learning algorithms that you use to solve your unsupervised machine learning problems. So I hope you liked this video, and if you have any doubts, questions, do connect with me on LinkedIn, and also you can leave the comment as well. And